Hey everybody! Today we're going to dig a little bit deeper into these coordinate proofs that we've been working with. We're on page 27 in your packet. All right, so here's another breakdown of how to prove things. If it's a parallelogram, you can prove opposite sides are parallel, so that's your slope. Opposite sides are congruent, which would be either distance or Pythagorean theorem, and diagonals bisect, which would be midpoint. So maybe let's jot that down. So this would be your four slopes. This would be for distance or Pythagorean theorem, a squared plus b squared equals c squared, especially if you have a graph. Or diagonals bisect. Since there's only two diagonals, it would be two midpoint. All right, so any of those would show it's a parallelogram. From there, you can show it's a rectangle by doing, you could do four right angles, but parallelogram, which we already have with one right angle. So just show that two sides are perpendicular. So you wouldn't have to do any work. You would just use, that would just come from what you already found in that up there with the slope. Or a parallelogram with congruent diagonals. So that would just be two distance, or a squared plus b squared equals c squared. All right, a rhombus. So one of these up here that shows it's a parallelogram with consecutive sides congruent. So that would be two distance, or a squared plus b squared equals c squared. Or a parallelogram with perpendicular diagonals, which would just be the two slopes of your diagonals show that they're negative reciprocals. Remember, if they're both a rectangle and a rhombus, they're a square. If they're neither, or if they're only one, then they're not a square. My favorite is six slopes, but we're going to look at some different ways to do it. So this first example tells us to use diagonals only. So let's go back up and see what it wants us to do. So to show it's a parallelogram, to show that the diagonals have the same midpoint. Which I don't have a parallelogram here. So parallelogram, which you have to prove before you prove these three. Midpoint of the two diagonals. All right, to show that it's a rectangle, we're just using the diagonals, show that they're the same length. So we'll do a squared plus b squared equals c squared for that. And a rhombus, show that the slopes of the two diagonals are perpendicular. So we're going to use midpoint, distance, or Pythagorean theorem, and slope. Because again, it wants us to do diagonals only. It won't specify. It'll just say to prove these, so you decide, but I just want to show you a different way. All right, so first thing, again, let's plot these points. So 0, 2, remember, all points are x, y. Since 2's in the y spot, it's on the y-axis. So there's our A. 3, 6, go over 3 up. Let's see, 2, 4, 6. 8, 6. 2, 4, 6, 8, 6. That'll be an easy slope. And 5, 2. 2, 4, 5, 2. So that one. All right, so use something with a straight edge. If you have a ruler, go ahead and use that. We're going to draw our shape here. Now, I can tell right away that it's not a square, but can we say that? No, you can't just say it's clearly, look at it, it's not a rectangular square, but you can't say that. You need to prove it. All right. So, and again, it says diagonals only. So let's look at our diagonals. One of our diagonals is AC. Oh my gosh, I did that in the last video. Hold on. Thought I had the line. All right. One of our diagonals is AC. And the other one is BD. Okay, so let's start with a parallelogram. Because in order to be all of these, it has to be a parallelogram first. Remember the symbol for that looks like the parallel lines, just connect the top and bottom. Okay, so in order to be a parallelogram, let's go back up. We want to show that the diagonals bisect each other. So we want to show that the midpoints are the same. Can we just say that that's the midpoint? No, we want to use the formula. So the midpoint, we'll just say MP, of AC is, let's see, we have 0, 2, and 8, 6. Remember, for midpoint, you're looking, it's the average of the two, so it's 8. 2 and 6 gives us 8, and then cut them in half, because 8, 8, if you look, 8, 8 is not the midpoint. So it's 4, 4. And if you look, 2, 4, 2, 4, that looks like it works. All right, so now do the same thing for the midpoint of your other diagonal. Again, I can't just say that's what it is. You want to show it, because sometimes it's a decimal or a fraction too. All right, so the midpoint of BD now, B is 3, 6. I'm getting these from right here. D is 5, 2. So 3 and 5 is 8, 6 and 2 is 8. Divide them, and we get 4, 4. So we got the first thing. ABCD is a parallelogram. And the reason, diagonals bisect each other. They have the same midpoint. You need to give some kind of statement. Okay. So now let's show that it is or isn't a rectangle. With a rectangle, you want to show that the diagonals are congruent. So you want to look at the length. So again, you could use your distance formula if you want, or you can make these into a right triangle. So for AC, and I'll even sketch it over here. AC is your hypotenuse because it's across from the right angle. It's the diagonal. And then we've got 2, 4, 6, 8, and then 2, 4. So 8 squared plus 4 squared equals x squared. 64 plus 16 equals x squared. So 80. And you could have just typed that into the calculator. Take the square root of both sides. So the length of AC equals square root of 80. And we'll leave it like that. We don't need to simplify right now. We'll just leave it like that. Now do the same for BD. Again, I'm going to sketch it so I can kind of see it out here, so it's not so messy. BD is your diagonal that you're looking for. That's your hypotenuse. This leg is 2, 4, and this one's 2. Okay, so we have 4 squared plus 2 squared equals x squared, or 2 squared plus 4 squared. 16 and 4 is 20. To get rid of the squared, we take the square root. So that means the length of BD is the square root of 20. Since 80, square root of 80 does not equal the square root of 20, they're not congruent, so ABCD is not a rectangle. And the diagonals not congruent. Okay. Run out of space. These are kind of long. Well, now we got to figure out if it's a rhombus or a square. Well, I already know it's not a square. Why is it not a square? Because it's not a rectangle. In order to be a square, it has to be a rectangle. So I'm going to make that statement now. ABCD is not a square. And the reason, because it's not a rectangle. It's got to be both. And since it's not one of them, it's not a square. Okay, so we've found out it's not a rectangle, it's not a square. Now you just have to show it's a rhombus. A rhombus, you want to show the diagonals are perpendicular. So we're looking at the slope of BD and AC. Lowercase m of AC and lowercase m slope of BD. And remember, you go from left to right with slope, rise over run. So for AC, we're going to get from A to C, always go from left to right. We're going up 1, 2, 3, 4 over 2, 4, 6, 8. Which we already did over here in our rectangle. We just went the wrong way. So we're going up 4 over 8. 4 over 8 is equal to 1/2. All right, the slope of BD, to get from B to D, again, you're going from left to right. You're going down, so it's negative, down to 4 over 2. Negative 4 over 2 simplifies to negative 2, or negative 2 over 1. So let's look at these. 1/2, is it perpendicular to negative 2 over 1? Yes, they're negative reciprocals. You changed the sign and you flipped it. So ABCD is a rhombus because the diagonals are perpendicular. Throw negative reciprocal in there too. You've got your work here to back it up. So it's a rhombus, it's a parallelogram and a rhombus, but it's not a rectangle, so therefore it's not a square either. That's a coordinate proof. Okay? All right, so pause the video for just a second. Get these points plotted. I'm going to do the same. And see what all these notifications are about here that keep interrupting us. All right, guys, so you should have plotted these points. If you haven't, make sure that you pause the video and do so. So just a reminder for n, 0, -4 is in the y position, so n should be on the y-axis. All right, so we want to determine or prove that it's a parallelogram, rectangle, rhombus, or square. Give all the names that apply. So again, you've got options. So if you want, we can do, again, I typically do 4 slope and then the 2 slope for the diagonals, but you can really do whatever you want. If you just want to do the diagonals, you can, like we did before. Let's see, I think I'm going to do 6 slope again. Because again, I just really like that. And in class, when we talk about this in class, and we'll be looking at other ones as well, we'll look and see if there's another method that you want to try. But again, if you just want to do your slope, or if you just want to do diagonals, you can do that too. Why don't we do diagonals? I'm going to change my mind. I know I'm all over the place. So again, if you want to use diagonals, like we did in the last one, if you show that the diagonals have the same midpoint, they bisect each other, so they're a parallelogram. If they're the same length, they are a rectangle, and if they are perpendicular, they're a rhombus. So why don't we go that route? All right, so let's determine first if they are a parallelogram. So I'm going to do KM. Again, you're kind of making them into a right triangle, right? Or, let's see. So KM, just so you can see it a little bit better, if we count squares, 1, 2, 3, 4, 5, 6, 7, 8, and then 2. All right, so the midpoint, or what am I talking about? I'm doing it the wrong way. I'm already on to rectangles. Never mind, we're going to do midpoint first. We'll save that one. That's for rectangle. All right, so let's do parallelograms. So the midpoints. It looks like it's negative, or Yeah, negative 1, 0, but let's check. So the midpoint for KM, negative 5, negative 1. Too early, I guess. All right, so we'll add those together. We get negative 2, 0, cut them in half, negative 1, 0, which is what it looks like on there too. Let's find, and this was the midpoint for KL, or excuse me, KM. Now we'll do the midpoint for LN and show that it's the same. So L is negative 2, 4, N is 0, negative 4. When we add those up, we get negative 2, 0, and when we cut them in half, we also get negative 1, 0. So we can say KLMP, LN, I don't know where the P came from, is a parallelogram because diagonals bisect each other. They have the same midpoint. You got to have those statements. All right, so we did parallelogram, and I like to mark it off when I'm done. Rectangle now, so let's go back over to what I was doing before. So rectangle, you want to show that they're the same length. All right, so KM is your hypotenuse. A squared plus B squared equals C squared. So 4 plus 16 is 20. Now just take the square root. So the length of KM equals radical 20. Now we'll do LN, which is going to be kind of a tall, thin rectangle right here. This will help with our slope too. We're going down 2, 4, 6, 8 over 2. I'm just going to label it. So when I do that, 8 squared plus 2 squared equals x squared. We also get 20. So when we take the square root, it shows that ln is equal to radical 20. So they're the same. So since Km is congruent to ln, KLMN is a rectangle. All right, I'm going to change colors here. So now we just have to show it's a rhombus. If it's a rhombus, it's also a square. If it's not a rhombus, it's not a square. So a rhombus just show that they are perpendicular. So again, the slope, which I find to be the easiest, of Km, you're going from K to M, you're going up 2 over 8, which we did over here. And again, you're going over 8, so you're writing over 8. So the slope's 1/4. The slope of ln, again, you want to go from left to right. Since L is further to the left, we're going to go start there. We're going down 8 over 2, which is the same as negative 4 over 1, or just negative 4. And if you look, negative 1/4, or positive 1/4, excuse me, is it perpendicular to negative 4 over 1? Are they negative reciprocals? Yeah, you flipped it and changed the sign. So now you can say KLMN is a rhombus because diagonals are perpendicular. And again, just say that their slopes are negative reciprocals. Okay, so there's another part of our proof done. Now a square. It is a square because it's both a rectangle and a rhombus. Again, if it wasn't one of those, it wouldn't be a square. So last statement, KLMN is a square because it's a rectangle and a rhombus. Ooh, okay. So there's a proof. Again, they're longer. These are usually the big point questions on the Regents. So just make sure that you hit each one. Again, I typically don't use diagonals, but I thought it would be, well, I don't want to say fun, but maybe kind of fun to try something different. If you want to do the slopes, you can. I like to do the slopes. But you'll notice coming up the 6-5 continued homework, you decide. Do you want to do 6 slopes? Do you want to do the diagonals? It's totally up to you. So we did the diagonals for both of these. Oops. Where am I going? For both of those examples. Not sure where that went, but we did. Okay, apparently I lost it, but we'll come back. Is it there? Oh, well. Anyways, if you look at yesterday's notes, I did one where it was all slope. Is it coming up? Is my writing going to be there? Whatever. Oh, here we go. Yay. No. Okay, this is going to take forever to load, so just remember there are different ways. So look back in your note packet, give the 6-5 practice a try, and we will talk tomorrow. Have a great day.